If the rate at which position changes is velocity, the rate at which velocity changes is acceleration. So ladies and gentlemen, the derivative of velocity is called acceleration. And since velocity was itself the derivative of position, we could say that acceleration is the second derivative of position. So two possible notations. A of t could equal dv dt, which equals d squared s dt squared. We could use the sort of function notation. A of t is v prime of t, which is also equal to s double prime of t. Here's a question from the 1985 multiple choice exam. If I have a position function, s of t, I'd like to find the acceleration of this particle at time t equals 4. Well, I want to find a formula for the acceleration at any time, and then I'll evaluate that formula for where time equals 4. You're going to do that about 100 times in the next couple of weeks. So the second derivative is what's going to give me a formula for acceleration. So I'm going to start by taking the first derivative. So that's the velocity is the derivative of position. And the 2 comes to the front and the 4 stays there. And I get 2t plus 4 for the velocity. I really want the acceleration, so I need the derivative of velocity. I'm going to find the derivative of velocity. It's going to be the second derivative of position. And it's just that 2, right? That was multiplying the 2t. So I have a formula now for acceleration. Acceleration at any time t just happens to equal 2. It's not always a constant, but it's a constant here. So what I want to do now is evaluate that function, that constant function, for when time equals 4. You can see I get a of 4 just equals 2. So the acceleration of the particle at time t equals 4 is 2. Right, this slide says it is important to understand the relationship between a position graph, velocity, and acceleration. It is very important. It's critical to your success in calculus. And it's also tricky. So just to start off a little bit here, we said that velocity is the derivative of position. And we know that derivative means slope. So at the beginning of this graph here, this distance function, the position function, is going uphill, right? It's increasing. That means the slope must be positive, which means the derivative of the distance function must be positive, which means velocity must be positive. So now we want to try to look at that slope. Is that slope a constant? If this looks like a line, the slope is a constant. But it doesn't look like a line here. The slope is like this, and then this, and this. It's getting steeper and steeper. So the slope of the slope, the acceleration, is increasing. Here in this middle section, again, the distance function, the function whose graph we're looking at, is increasing, so velocity must be positive. Is the velocity increasing or decreasing? Well, if you look at that section, ask yourself, does the slope of that section increase or decrease? Well, that section kind of looks like a line, and for a linear function, slope doesn't change. So we would say that here, the velocity is constant. It's not changing. It's positive. It's a positive constant. Here at the top, near the top, right before the top, this function is still increasing. The function I have a graph of, which is the distance function, is increasing. So I know its slope must be positive. Its slope is velocity. Velocity must still be positive. Is it positive in the same way all the time? Is it a constant positive? No, because you can see that here, right before it hits the top, the graph of distance is flattening out. So it's still increasing, but it's not increasing as much or as much or as much as we approach this peak here. So we would say that the velocity is still positive, but it's positive and decreasing. That means the acceleration is negative. So for the whole second half of the graph, the distance function is decreasing, which means the velocity is always going to be negative. This section, the velocity is negative, but it looks like a linear function, so it's a negative and staying constant. Here, at the very, very end, the acceleration and velocity both come down to 0.